Algebra 2. Today we're going to take a look at the quadratic formula. Our goal is to solve quadratic equations using the quadratic formula and to determine the number of solutions by using the discriminant. Now you should be familiar with the quadratic formula and how to use it from Algebra 1. If you look at page 285 in your textbook, it goes through a proof. Now I have that written out here, and it is definitely a higher level thinking math, but I always think it's good for you to take a look and see where this proof comes from. I'm not going to go through and explain it in this video, but I will attach a link of a video in Plan Book if you would like to see how this proof breaks down and where it comes from. But basically, all you're doing is you're taking this quadratic equation and you're solving it for x. And if I go through and solve this quadratic equation for x, once we go through and solve that, we will see in our last step that we end up with x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a, which you guys should know as your quadratic formula. Okay, so let's take a look at problem number 1. Use the quadratic formula. What are the solutions? So when using the quadratic formula, we need to have one side of our equation equal to 0. I always like to keep the quadratic term with a positive lead coefficient. So I'm going to just go ahead and remove the 4 by subtracting 4 from both sides. So it's minus 4, and we're going to end up with 2x squared minus x minus 4 equals 0. Now that you have that done, you want to identify your a, your b, and your c terms. We know that a is equal to 2. Our b term in this case would be negative 1, and our c term would be negative 4. So now we go through and we use our quadratic formula. We are going to have x equals opposite of b. Opposite of negative 1 is positive 1, plus or minus square root b squared. Anytime you square a number, you always write it in parentheses. Negative 1 squared minus 4 times a, which is 2, times c, which is negative 4, and you're going to put that all over 2a. So then you take your calculator and you type this in. Negative 1 squared minus 4 times 2 times negative 4. Type it in exactly as you see that. And when you type that in your calculator, you should come out with 33. And that's all over 4. Now, this is the exact answer. 33 is not a perfect square, and 33 does not break down, so this is the exact answer. Okay, now you could come up with 2 decimal solutions as well, but many times you're going to see that they're going to prefer exact answers. If you did find the decimal approximate solutions, you put approximately x equals, and you're going to do 1 plus the square root of 33 divided by 4, and you have to be careful when using your calculator for that. When you use your calculator, you do 1 plus square root of 33, you have to hit enter and then divide by 4. If you don't, you're going to get the wrong answer due to order of operations. So this is approximately 1.7. And the other answer would be 1 minus the square root of 33 over 4. So you're going to do 1 minus the square root of 33, maybe here, 1 minus square root 33. Hit enter and then divide by 4, and you're going to end up with approximately negative 1.2. These are the approximate answers. This here is my exact answer. And when we are solving this equation, this quadratic, and setting where our output is equal to 0, where our y value or f of x is equal to 0, we're actually finding our x-intercepts. So in this case right here, our parabola is going to cross the x-axis at approximately 1.7 and negative 1.2. All right, so pause the video and let's see if you can come up with a solution to the next question. Okay, let's see how you did. So you should have identified your a is equal to 1, your b is equal to 6, and your c is equal to 9. You go through and you plug it in to your quadratic formula, and you're going to find out that this becomes 36 minus 36, which gives you a value of 0. Now, when I take the square root of 0, it's just going to be 0. So here I have negative 6 plus or minus 0. Adding and subtracting 0 will always give me the same outcome. It'll still be negative 6. So really, I'm only going to have one solution. It's just going to be 6 over 2, so x equals 3. So when we see that we have a value of 0 under here, our output will be only one solution, and this tells me my parabola is going to cross the x-axis at 3. Okay, so let's take a look at the next question. It says your school jazz band is selling CDs as a fundraiser. The total profit P depends on the amount X that your band charges for each CD. The equation P equals negative x squared plus 48x minus 300 models the profit of your fundraiser. What is the least amount in dollars you can charge for a CD to make a profit of 200? Okay, so let's note some things. What does X represent? X represents the amount your band charges for the CD. And this function right here is the equation that models the profit. So X is the amount charged, P is your profit. And the question says, what is the least amount? So what is the lowest amount that you can charge in order to make a profit of $200? So we see from here that our P value is going to be 200, and we're looking for the X value that's going to give us that. So we're going to take our equation right here, and we're going to plug 200 in for P. So I'm going to go over here, and I'm going to put 200 is equal to negative x squared plus 48x minus 300. Okay, so our goal is to have everything equal to, we have one of the sides equal to 0. Now again, I typically like to have my x term become positive, my quadratic term be positive. You don't necessarily have to, but if you are going to ever solve by factoring, this always should be positive. But we can go ahead and subtract 200, or we can just move everything over to the other side in order to make it positive. And that's what I'm going to do just because that's what I like to do. Okay? All right, so I would add an x squared. I would subtract a 48x, and I would add a 300, and that would get the side equal to 0. So then over here, I'm going to add an x squared. I'm going to subtract a 48x, and then I'm going to add 300 on this side. And when we go ahead and do that, here's what we're going to be left with. X squared minus 48x, 200 plus 300 becomes 500. And we set that equal to 0. So we're going to have A is equal to 1, B is equal to negative 48, and C is equal to 500. And we can use our quadratic formula in order to solve this. So we're going to have x is equal to the opposite of b, so that's 48, plus or minus. We're going to have the square root, and it's going to be b squared, negative 48 squared, minus 4 times a, which is 1, times c, which is 500. And we're going to put that all over 2 times 1. So get your calculator and calculate out what's going to be underneath that square root. So you're going to do 48, actually negative 48, but it doesn't matter because negative 48 and positive 48 squared are the same, minus 4 times 1 times 500, and you're going to end up with 304. X is equal to 48 plus or minus the square root of 304 all over 2. So we're going to have two solutions. We're going to have x equals 48 plus the square root of 304 over 2. And we're going to have x equals 48 minus the square root of 304 over 2. So you're going to put those in your calculator, and they are going to be approximate answers. So remember, when you do this, you're going to do plus the square root of 304, and you're going to hit enter. And then you're going to go ahead and divide by 2. And you're going to end up with $32.72. Now, it was talking about how much you should charge, so that's why I went to the nearest penny. Now, when we do the other, 48 minus the square root of 304, that becomes 30.56 approximately. You're going to divide that by 2, and x is approximately $15.28. Now we have two different amounts that we can charge in order to get a profit of 200, but to answer the question of the least amount, we are going to choose $15.28. That is the least amount we can charge in order to get a profit of $200. Okay, so here's what we know about a quadratic equation. A quadratic equation can have two real solutions. If I was to solve x squared equals 4, we have two solutions, plus and minus 2. It could have one solution. If x squared is equal to 0, when I solve this, obviously as we saw earlier, plus and minus the square root of 0 is just 0. Or it could have no real solutions, such as x squared equals negative 4. We know when we solve this and we take the square root of negative 4, we're going to have imaginary solutions. We would actually have two of them, of plus and minus 2i. So in the quadratic formula, the value under the radical symbol, b squared minus 4ac, tells you how many real solutions exist. This is called the discriminant. So b squared minus 4ac is called the discriminant, and that value under here tells you how many real solutions exist. So when I read this, it says when b squared minus 4ac is greater than 0, that means when it is positive, we will have two real solutions. So that means when I will solve it, I will have two x-intercepts. That means my graph, my parabola, will cross the x-axis twice. So the graph could open up and cross twice, or the graph could open down and will be crossing twice. So when we have two real solutions, that means you have two x-intercepts. Again, when we're solving using the quadratic equation, because setting our equation equal to 0, we're finding our x-intercepts. When our discriminant is negative, not when it's negative, when it is equal to 0, we see that we will only have one solution. So when it is equal to 0, we're going to have one real solution. So if we only have one real solution, that tells me I'm going to cross the x-axis at one point. We would have one x-intercept. So you can sketch a graph showing two different options of it opening up or down where you have one x-intercept. b squared minus 4ac, when it's less than 0, that means when your discriminant is negative, you will have no real solutions. So if we have no real solutions, that's going to imply that we have two imaginary solutions. Okay, so I'm even going to add that below in parentheses. No real solutions mean there's two imaginary solutions. And one of the things that we're going to start to learn is that imaginary solutions will always come in pairs. They'll never be an odd number. So because it's quadratic, we would have two imaginary solutions. So that means if there's no real solutions, how many x-intercepts are you going to have? You're not going to have any. You're going to have 0 x-intercepts. So what does that mean for your graph? That means my parabola is going to be above or below the x-axis and never cross. Both of these parabolas have no x-intercepts. So when you see these types of questions, which you will see on SAT as well, when they talk about what's the number of real solutions, you don't actually have to go through and solve the entire equation. All you have to do is figure out the discriminant value. So we take a look. We have this quadratic equation. It's set equal to 0. We know our a term is negative 2. We know our b term is negative 3, and our c term is 5. So we can go through and we can calculate b squared minus 4ac. And when we calculate that out, that becomes negative 3 squared minus 4 times negative 2 times 5. And when we calculate that out, that becomes a positive 9. Negative 4 times negative 2 is a positive 8. 8 times 5 is 40. So that's 9 plus 40. That is equal to 49. And we see that 49 is a positive number. And when our discriminant is positive, we're going to have two real solutions. Okay? So same thing for the last one. Go through and try it. Identify your A value should be 2, your B value should be -3, and your C value should be 7. So you're going to do B squared minus 4AC, and you're going to plug that in. So you're going to have a -3 squared minus 4 times 2 times 7. And that will end up giving you a -47. And again, when our answer is negative, that means we would be taking the square root of a negative number. We will have no real solutions.